Hey everyone, welcome to the VMware Cloud Networking Academy presented by 27 Virtual. Today we're going to take a look at the basic NSX-T overview and use cases. This is presented today by yours truly, William Grismore, NSX-T Architect. Welcome to the presentation. Today we're going to cover an overview of NSX. As you can see, the NSX portfolio is quite large and expanded over time. When we first started out on our journey with NSX, our original focus was on the NSX data center product, and that's still a very prevalent core feature of NSX. It has expanded greatly. We now have NSX Cloud, the ability to extend NSX networking and security components into public cloud natively through Azure and AWS. We've also added in NSX Intelligence, the ability to get a better understanding of traffic flows. We've also recently added the NSX distributed IDS and IPS feature, which is going to be enhanced over time. So NSX has grown as a product and has quite a few features that we can take advantage of in our data center. There's also the AVI load balancer and service mesh, and the ability to migrate workloads with the NSX Hybrid Connect utility, which makes moving workloads back and forth to the public cloud much easier than ever before. We can also use that tool within our data center if we just need to migrate from, say, a legacy 5.5 vSphere to a new 6.7. But this is where our focus will be today, is on these main core products across this bar. So NSX is a complete solution. So NSX is going to provide everything you need from a networking and a security standpoint, core route, switch, and firewall. But we have added NSX IDS IPS, a subscription service you can take advantage of to allow you to, just like with micro-segmentation, take security and add it into the kernel of your ESXi host. The AVI Advanced Load Balancer and Service Mesh for application for modern applications to secure those modern services. And then we also integrate with the SD-WAN platform, giving us a true end-to-end solution and networking security both in the data center, on the edge, to your branch offices, everywhere, with full integration of NSX security included also in the VMware SD-WAN platform. So it's integrated, it's simple to deploy, and it's enterprise grade, proven and tested in large enterprises today. Another interesting aspect of the new versions of NSX that we have today, NSX-T, is that not only does it work in your data center for your vSphere platform, it also works on containers. It also supports public cloud workloads, native AWS and Azure workloads. We also have the ability to protect bare metal workloads. So we can actually install an agent on a Linux or a Windows machine and extend the reach of the security, not only in the data center rack, but out to legacy physical servers, or in many cases, databases that cannot be converted into a VM. All these solutions are in place with NSX today and can stretch within the data center to the cloud and to the edge, giving us a product that's very dynamic, but also static for those physical workloads. At a very high level, we're going to break this presentation down into first networking, then security, and then we'll do a brief look at automation and a quick look at native cloud integration. So let's get started with networking. So if we take a look at the data center the way it is today, what we're looking at is deploying a ESXi host, outlined here, deploying virtual machines, and building virtual networks. So we could say that today we do have virtual networks, and that is a true statement, but we're still tied to the physical world. And what that means is that I build a port group and I assign a VLAN, and I need to make sure that that is trunked on the outside world, either explicitly with multiple VLANs tagged or the entire range trunked on those ports. As we add more workloads, I may add yet another network. The virtualization admin builds this network, then I have to reach out to my network team if it's not already pre-trunked, and I have to trunk that additional VLAN. We also don't necessarily, in most cases, recommending trunking all on the physical due to security concerns. It is a common practice, but something that most organizations that have tighter security try to stay away from. Again, if I'm still in this world the way we have it before NSX, I create another port group, I assign a VLAN, I need to make sure I trunk that specific VLAN in addition to the ones already there, or again have a trunk all on the physical network. So again, virtual network segments, but we're still anchored, if you will, or tied to a dependency on the physical world for the network team or the network administrator to actually provision that VLAN on our physical top of rack switches. And then when the VMs want to communicate, one thing that's very important to point out here is the traffic flow. So if VM1 wants to talk to VM2, now they're sitting on the same host, you would think they'd be able to communicate directly to each other. And they do talk to each other, but it's not really a direct path. So what happens is VM1 must leave the network, go out across this purple line here, find his layer 3 device, maybe all the way at your core at the very top of your environment in traditional 3-tier network architecture, come back down, possibly come back to the same port, and then arrive right here and then talk to this VM. So even though the two VMs are sitting physically on the same host, right next to each other, maybe even in an adjacent memory space, they have to traverse all the way out and come back in. So we refer to that as hairpinning. So the question I always like to ask here, does that really make a lot of sense to have to go through that kind of a process for those VMs to talk to each other? And I think the obvious answer is no, it really doesn't make a lot of sense. It could be functional, maybe there's good enough performance. We don't really see much latency there because the data centers are so fast today, but we can make it even better and make it more efficient. And also keep in mind, this is just a network perspective we're looking at right now. We're gonna look at the security in just a minute. So what we wanna do is build an environment where the virtual networks are truly abstracted from the physical network. So what we can do in NSX networking is we can implement a layer of network abstraction, and that's what's represented here by this purple line. So this is a set of tunnel endpoints, or TEPs for short. And what these TEPs will do is encapsulate traffic between each other, between hosts. So if a VM on this host wants to talk to a VM on the other host, we're going to take the traffic and move it from host to host, TEP to TEP. So that's going to be a huge advantage, especially when we get into multi-data centers across a WAN link. So the idea that we had in the previous slides, as I go back, is that we're building VLANs and we have to match that on the physical. What we're going to see different here is I'm going to build one VLAN one time for the TEPs. And after we build that abstraction layer, just like we do with our hypervisors for compute that we're used to, I can now build an environment that looks like this. And what we've done is created software routing and switches all in the kernel of your ESXi host. So what we can see now is when we start looking at traffic flows, the same drawing we had before where the two VMs were talking to each other, now these VMs are talking to each other. They're plugged into a port group, but it's not a VLAN, it's a virtual network identifier. It's a special number that's similar to a VLAN, but uses a different construct for communications and tracking and pinning IP addresses and so on. So VM1 to VM2 is now going to go through a router that sits in the kernel of your ESXi host. We go across this router, we make a very simple next hop decision and talk to VM2 right on the same host. Isn't that amazing? All that hairpinning that I had drawn out before has been completely avoided. And you could even increase performance of applications today by using affinity rules or some other scripted technique to try to keep those machines on the same host. It may not always be possible, but when you're planning your deployment of your workloads, it's definitely something you could keep in mind. The other thing here also is if VM1 wants to talk to VM4, now they're both on the same network, which is 5,000. What's going to happen is that when these VMs talk to each other, we only have this one VLAN provisioned. You'll notice that all the way out. And that's the VLAN for the TEP. When these VMs go to talk to each other, we don't have to go through this router. We don't, because they're on the same segment. So we're going to leave the host here. We're going to leave through this TEP. We're going to traverse here. We're going to come in here. We're going to arrive on one of these two TEPs. And then the traffic will drop right on this port and then come into that VM right there. So VM to VM communication on the same host, very efficient. VM to VM communication between hosts, as I just drew out there, is enhanced in a way so if there's a layer 3 boundary, say between data centers, we can very easily traverse that boundary. I'll do one last traffic flow here. If I go to VM1 and VM5, now in this case, VM1's on the VNI 5000 and VM5's on VNI 5001. So what will happen is we're going to leave the VM, we're going to use our gateway because this VM's on a different network segment. We're going to go to this T1. Notice this T0 I have drawn here is not used. We're going to make a route decision and we're going to leave the router here, but that VM5 doesn't live on this host. He's not plugged into this network here. So the traffic will leave the host. We're going to use the TEP. We're going to encapsulate the traffic, move it across the network. It's going to arrive in here, come in on this TEP, get decapsulated, arrive right on this port right here and come to this VM. So we're doing software-defined routing and software-defined switching. And when we move the traffic from host to host or TEP to TEP, we're tunneling the traffic. So if those hosts are on the other side of a layer 3, either in another rack, in my data center, at another data center, or in the cloud, we can stretch that layer 2 network. The tier 0 that you see here, the tier 0 is used when we're going to go north-south. If I'm going east-west, we only touch the T1. So it's a built-in router that allows you to move traffic across your environment. If I want to go north-south, what we're going to need to do is leverage something special called an edge node. And the way I like to explain this when I'm done is we're basically building what I like to call an ice cream sandwich. That's really all it is. What we're doing is building 2 layers, and the additional layer that we have is this edge node that sits here, and we have a special T0 SR that's going to route us north. So if I want to get out of my environment, traffic's going to leave, say, from VM1. We're going to leave the interface of the VM. We're going to get routed at my T1. The traffic's going to leave the host because I'm trying to get to the outside world, outside my network. We're going to go to this TEP. We're going to leave the network. We're going to arrive on this TEP. Now, I don't have every single bit of the underlying network plumbed out, but you can imagine we're going to have a physical connection here. The traffic's going to come into this ESXi host on a VLAN and get passed to the TEP inside an edge node. The traffic has already been routed by the T1. So it arrives right here at this point on this tier 0. It's going to go north, go to an SR router, and be able to traverse and leverage BGP or static routes to go north-south in and out of our environment. So there's some very interesting traffic flows that happen, but at a very high level, all we're doing in NSX is creating an ice cream sandwich. If you think of it this way, there's a top layer here, and there's a bottom layer here with your TEPs. And everything in the middle is what we do in software, software-defined routing, software-defined switching, moving traffic east-west across our environment, or if necessary, all the way north-south. So we have to have a layer of abstraction on the bottom and a layer of abstraction on top to get out to the outside world. And that's really what the NSX networking brings. The ability to do routing and switching in software and to be able to move traffic back and forth very easily. All this graphic does is just shows you that the TEP can actually be stretched. This network can be stretched between multiple data centers. It could be multiple racks in the same data center, but we're stretching that TEP all the way across into another data center, into the cloud, wherever you want to extend that network to. So we can actually have VMs that sit in one data center that can talk to VMs in another data center. It's the magic of software-defined networking. Another great thing about NSX is just not the networking aspect of it, it's the distributed nature of what it does for all the other services. So for example, in this case, we're talking about looking at how things would be in a physical rack. So the same thing I just showed you, like the different network segments, the different color segments the VMs are plugged into, imagine them stretching across the physical servers and moving through the routers in your environment from one VM to another. In this case, 2 VMs again on the same physical host using one of those routers in the kernel of the host. Very, very powerful processors and performance to make that happen. So a view of it logically and a view of it physically in your environment. We also have the ability to leverage multi-cloud networking. We're able to move workloads from an on-prem data center into a public cloud. And that public cloud, again, could be Amazon or it could be AWS. We can actually have instances of VMs running on the different platforms and have security be consistent and have networking be consistent across those clouds with the simple operational policy. Imagine having the ability to have a workload sitting on-prem and migrate it to the cloud, or burst when you need to. Those situations are very, very useful. And because we can have consistent security, we can plan and build policies for that. We also get great visibility. We can use tools like vRealize Network Insight or NSX Intelligence to have traffic flow visibility, and also hardware independence. It doesn't really matter what the underlying hardware is at all, because everything is defined at the software layer, giving you great flexibility. So this puts you into that multi-cloud era, and then we can have a single dashboard of the cloud service manager. There's an extra appliance that we'll deploy in an NSX deployment that gives us visibility into our workloads up in the cloud, and we can actually monitor and see the VPCs or the VNet instances we have running up in the cloud. We can see it by account, by region, and so on and so forth, and have that single pane of glass to monitor. A new feature that's coming with the latest version of NSX, NSX-T 3.0, is something called Federation. Federation is a pretty exciting feature. What Federation allows us to do is have a central set of managers called the global managers that kind of sit on top. And then each one of these individual locations, primary, secondary, will have their own set of 3 managers that sit in a cluster. And the great thing about this is we don't have to worry about failing over the management cluster as we did in previous versions, or even all the way back in V having a primary and a secondary. So instead of having a primary and a secondary like we did in NSX for vSphere, or having a management plane that we must fail over as it is in the current versions of NSX, we instead have separate local managers, and then we have a global manager. It gives me a consistent policy framework that I can use to implement policy consistently across all these different environments. And then the local managers push the details down to their local ESXi host within their area, even to AWS. Either AWS running VMware Cloud on AWS, or AWS natively and Microsoft Azure natively. We support all those different platforms. So imagine having an on-prem data center, VMware Cloud and AWS, and having separate NSX managers and a global manager, giving you the ability to enforce global policy across all of your environments. It gives you a lot of flexibility. The thing that's not shown here in this graphic is we'll have basically 2 sets of global managers. There'll be 3 global managers at, say, location A. There'll be 3 global managers here. And then we'll have a set of standby global managers. So that way we can actually also have a highly available global manager management plane. I can also still create objects locally with the local managers, so that I can have, like in the graphic that I showed earlier, I can have those T0s and T1 routers and switches just in location B, just in location A, just in location C, all independent of each other. Then I can have an other set of stretched tier 0 and stretched tier 1s and stretched network segments that span all of those locations all the way to the cloud. I can also have these global policies for security that stretch across all of them as well. So independent route switch at each location potentially, and then also global route switch that spans all the locations. So it's a very powerful feature, and from a management standpoint, it's something to be very excited about as we move forward with NSX in the future. So Federation use cases give us consistent security, again, from the global manager. Simplified disaster recovery, much easier to flip over, basically one click almost, and we can flip over to that other data center and take that secondary global and make it a primary. I don't have to recover a management plane. And then very efficient metro data center pooling. You can build a stretch cluster and stretch storage within a metro if you have a 10 millisecond or less latency configuration, and leverage that in those environments as well. So that's it for the networking. So the networking, in summary, there's a lot of features there, a lot of capabilities, but remember the basics. The most important thing is you're stretching the layer 2 across multiple data centers using a tunnel endpoint. We're creating what I like to call an ice cream sandwich. So we have a network abstraction layer. We like to call it the network hypervisor with the TEPs, and then the edges do the northbound abstraction. Everything in the middle is the soft and gooey middle that you can do whatever you want with in software. And then now we have this new capability with Federation to make the ability to have multiple data centers much more rich. I believe the current version is going to be 4 or maybe even up to 8 when the 3.0.1 release is out. The 3.0 release right now currently supports Federation only in a POC. The other main feature that NSX brings is security. So security is very important in today's data centers. What we want to do is take security to the next level, essentially. We all have a physical firewall that we have in place, and we absolutely 100% must keep that physical firewall. We're not trying to get rid of the physical firewall. However, what we can do is reduce some of the workload on that physical firewall. And what we can do is move some of the work that we would do at the firewall physical level and move it down into the kernel of your ESXi host. So now we would have a firewall on every single workload or container across our environment. The use cases are micro-segmentation for regular production workloads, secure end user computing for your VDI environment, and one of my favorites is DMZ Anywhere. Imagine, like we showed you in the earlier slide, where you have a separate set of edges, a separate T1 and Tier 0 just for your DMZ workloads, and then you microseg them. You could even take that all the way to a zero trust environment. And again, very important, the endpoints can be VMs, bare metal, Linux and Windows now, containers, workloads in AWS and Azure by installing agents in those VMs up in the cloud. So a solution for everything across the board from a security standpoint. We've also integrated intrusion detection and intrusion prevention in the current version of NSX. So the IDS IPS feature is going to allow us to have in kernel distributed IDS protection. The benefit of that is that when traffic is coming into a VM, we have, first of all, we have the micro-segmentation in place to really lock that workload down. And the thing I want to point out about the micro-segmentation before I go further with the IDS is just remember that with micro-segmentation, your VNIC is where the security enforcement point is, which is outside of the VM, which is very important. All the security controls are right there in that sweet spot, or what we like to call the Goldilocks zone. Not too close, not an agent in the VM, and not too far away, like out on a physical appliance somewhere. It's right in that hypervisor sweet spot, if you will. We're now doing the same thing with the ability to have IDS, IPS built into the kernel in that same area. It's not in the VM, it's not an agent. We're not installing any agents in there. It allows us to not worry about deploying appliances across our host and maintaining those appliances. It's built right into the kernel. It is a subscription-based SaaS service that you can subscribe to and add those additional capabilities into your environment. We do leverage a curated signature distribution from one of the top security entities anywhere in the world. That same engine is used by many of the other third-party vendors that VMware already works with. It is context-based threat detection. It can actually look into those signatures and learn from them as well. And it's policy and state mobility. We can actually look to see if we have redundant policies and keep our design of our policies clean and make sure that there's no stale entries in there or no holes in our security. One thing that's important about this concept, as I just alluded to on this little picture here, up here on the left, is that it's integrated versus bolted on. And that's really what this is saying. This is my VM. I could put an agent in the VM and bolt on the security, or I could have it integrated in the kernel. So what we can see here is imagine having some type of firewall that we use, like a physical firewall that sits in our data center. We're going to take the exact same concept of that physical firewall. We're going to cut it up into whatever pieces we need, our 16 hosts in our rack, and we're going to insert that right in the kernel of each one of those hosts, right in that Goldilocks zone or that sweet spot. And then the enforcement's done there. One analogy I heard one time that I thought was really good is that when you think about the security, it's kind of like if somebody breaks into your home and they can very easily get to the alarm panel somehow and turn it off. Maybe outside your house, they can just clip the wires. Or if it's inside your house, they can easily get to the controls and turn them off or figure out a way to circumvent it. By having agents in a VM, it's a very similar challenge. Now, I'll give the third-party vendors a lot of credit. They do a good job of locking that down to make it very difficult to be able to turn that security control off. But where there's a will, there's a way. Why even take that risk? If we could have security control somehow buried deep in the backyard of our house, where the bad guys would have no way of knowing how to get to, or even if it was there, if they start digging a giant hole in my backyard, I have bigger problems, right? So the idea is to bake that security in and make it very intrinsic within your environment. The same thing with the IDS IPS. We're taking something that would normally be an external appliance, or maybe appliances that we have to deploy across our host, and again, we're baking it into the kernel. It's the best spot to have that security on those virtual machines in your environment. And keep in mind, we still now have the agents for our physical Windows and Linux machines to complement this as well. So we can build IDS IPS rules to protect our applications, whether it's going to be a web tier, and then those policies get pushed out to hosts by that NSX manager that we talked about, whether it's the global manager policy or a local manager policy. We push that policy out and we force that across all of our hosts. We combine that with our firewall rules. So we have firewall rules to control what port we can talk on. We also have network rules that control kind of what happens on the segment. That's really beyond the scope of this intro course, but there are some other things we can do on a segment level, like basic things like whether I talk to a DHCP server or not, or those type of things. So I have all these basic things in place, and then I add on top of that the IDS IPS, and I get a very elegant solution. And that enforcement, and I think this is really important, this enforcement we're talking about is on the VNIC of every single VM. It's like having a little mini firewall and IDS and network policy that sits on every single VM, whether it's a regular web front end or the application or the database tier. And if the database happens to be physical, we do have the ability to apply policy there as well now. When I deploy a new workload, those security policies get added automatically, either based on tagging or by position within the environment. So it's kind of almost like a set it and forget it. We build this out, we put everything we need in place, we have everything we need. Oh yeah, and by the way, when those workloads move from one host to the other or to the cloud, that public cloud, that hybrid cloud environment, with the proper configuration, we can ensure that those policies actually follow the VM no matter where it goes. It's a no-brainer. No matter where machines sit, no matter where they're talking, we have consistent security implemented. VMs are talking to each other. We don't have to worry about the lateral spread of malware within our environments. And keep in mind, on top of this, we still have our physical firewall. Those are still in place. So the big new feature with NSX-T 3.0 is the IDS IPS. So it's going to help you with your regulatory compliance, especially if you're doing anything with PCI, credit card processing. It can generate reports to prove and validate role-based access control, who had access, when they had access to it, and the policy enforcement, which is the type of reporting you need for different types of compliance organizations that may do an audit. It helps you eliminate blind spots. The virtualized DMZ, again, the ability to take some VMs that are DMZ VMs and put them on the same physical host as production workloads. It's okay. You can actually do that now. Now, it may take some educating to your security team to get that to be approved, but it's all been validated by third-party security entities that can prove that out. You can do a proof of concept in your environment to prove that you can do that. You don't have to have a completely separated stack, a separate rack, a separate switch, a separate router, and a separate path for everything anymore, right? It's a waste of resources. Hey, if you have to do it, you do it, but if you can convince your teams to leverage this, we can prove it out, and it's being done today by very large enterprises in production. Discrete application consolidation, basically the same thing I just said. We can have the ability to mix things together and have a policy in place, right? And we can also make sure that the appliances that are used for this live in a centralized location. We don't have to put appliances on every single host. So there'll be a service set of servers or virtual machines, appliances that sit on your host that you will steer the traffic to do that inspection, so you don't have to deploy the appliance across every single host anymore. You actually still can do that if you want to, but it's not a requirement. Lateral movement detection, again, I can see what's going on within my environment, east-west, inside my data center. So these solutions work also for our cloud-native applications. So if I'm building an environment with PKS, I can support that. I'm using the new version of vSphere 7 with Kubernetes integrated into vSphere, where an actual container is managed by the kernel, just like a VM. Not an appliance running the container, but the container directly in the kernel of the ESXi host. We can take advantage of the Tanzu container grid, where we can actually reach out to things like PKS, standard industry network container plugin infrastructure support for Cloud Foundry, and Kubernetes. We can also leverage APIs, if you kind of break this down. APIs with OpenShift, so Red Hat OpenShift and any other new platforms. The NSX Manager API is a standard open set of APIs that can leverage and reach out to and provision networking and security for all of these different platforms. So whether it's a container in core vSphere or it's a PKS container, NSX has either a plugin component or an NSX Manager API that can allow us to deploy networks and allow those container network interfaces to connect, and we can implement security on those connections. So a broad support for future building of cloud-native modern applications now in NSX-T. So it gives you a lot of flexibility. And we can also support this across bare metal servers. And we also support the ability to stretch networks also to KVM hosts. So one thing that's important in NSX-T is it's for vSphere, it's for KVM hosts, it can stretch to KVM hosts, and it can also support security on bare metal and to the cloud. And that cloud can be VMware Cloud on AWS, where you spin basically a vSphere environment up on a VMware Cloud Foundation validated design in AWS, or it can be native AWS and native Azure. There's also integration with products from other vendors like Cloud Simple on Google Cloud, where they build basically a full vSphere stack. And the same thing is true also in Azure, where they basically build a full vSphere stack on the Azure Cloud hardware up in their data center. So full networking security for all your modern application needs is something that NSX brings to the table. And again, built into vSphere is the ability to have Kubernetes. So another important part of this, this is all based on open source to allow developers to deploy their containers and have those containers on demand, which is very important, on demand, create networks, and through security tagging, which we didn't even talk about yet, we have another section on that as well, is leveraging security tags to VMs, to containers, to make sure that the network is deployed, the container network interface plugs into that network, and then we have the security policy in place to take advantage of that. We can also leverage things such as NATing, the firewall, and load balancing for all these different services, right? And we can build the vSphere supervisor cluster, and we can leverage the core vSphere Kubernetes, or we can deploy a guest cluster, and we'll have a tier 0 for the north-south out to the physical network, and then the actual workloads will plug into segments that are connected to an NSX-T tier 1 network. And then we can substantiate services for that tier 1 as well in our NSX Edge service cluster, which basically is just another set of VMs, 1 or 2, typically at least 2 for fault tolerance, of course. They're either dedicated to providing services or where my north-south routing takes place. Another important aspect, which we alluded to a little bit there, is automation. We have some customers that say, if I can't automate it, I don't do it. And I like that mantra. Of course, that's hard to do for a lot of customers, but I would say wherever you can, automate. And the great thing about what NSX brings to you is because we have this ice cream sandwich, if you will, where we have this abstraction on the bottom between the ESXi host and the physical network for east-west traffic, which is the TEP, and we have abstraction for north-south, which is the edge, and everything in the middle is that kind of that software-defined networking where you can build all your routers and switches and segments and implement your security either on-prem or in the cloud. Because of that abstraction, because of that ice cream sandwich, all that stuff in the middle can be automated. So if I'm sitting in VRA and I want to deploy a workload, the way it used to be before NSX is you'd have to pre-create those network segments that your VM workloads are going to plug into. And you can still do that today, and I'm not saying that you can't or that you shouldn't, but where possible, we want to try to minimize pre-creating or pre-staging things. And the primary reason we want to eliminate that is, number one, there's some resources that get used when we do that. And number two, inherently, it's just not very secure. If I start pre-staging something, it's out there, it could get consumed by somebody else. Also, when it comes to security, what I can do now is leverage security groups and security tags to create my 5-tuple source, destination, service, firewall role enforcement, so that when the workload gets deployed, think about this for a minute. I'm automating application XYZ, classic three-tier app. Going to deploy the database. It's going to place that database in a group by leveraging a security tag. It's going to deploy the app tier. It's going to tag it, put it in a group. It's going to deploy the web tier, tag it, put it in a group. And even better yet, on demand, it's going to create a network segment that those VMs can plug into. So all the way from beginning to end. And then the other part of it is that it's part of a lifecycle management. So when you tear those workloads down, that network goes away. The machine drops out of the security group. So in the kernel of the host, that particular entry is gone. I mean, the rule is still there, but the individual IP address is removed out. So it kind of cleans itself up afterwards. And we can do this for regular IT as a service where my IT staff no longer has to add and build Windows machines or servers manually and copy them from the template and all the things that go into that. Or it could be for my developers where they're actually spinning up containers and taking advantage of Kubernetes and the inherent security that we get with NSX networking there. So automation across the board with NSX networking security built in. Some new features in the latest version of NSX-T. The NSX Federation, a huge feature that's going to be maturing over time. GovCloud support for AWS and Azure. Multi-tenancy at scale, EVPN support and multi-VRF as well. And dynamic network service chaining as we add more network security services. The IDS IPS feature, huge, huge feature in NSX-T 3.0. NSX intelligence for application-based. You know, when you go to build firewall rules, how do you know what ports to block? This will help you with that. Layer 7 edge firewalling now instead of just in kernel. So if you want to do layer 7 deep inspection, we can do that at the edge, not just at the host. And now distributed firewall for Windows 2016, physical servers. That's right. You can actually install an agent on that physical Windows 2016 box and get the same security you get on a VM. It's fantastic. Expanding the reach. And then the full set, everything we just talked about for the modern apps. Full support for NSX-T with K8, namespace isolation, cluster API integration, and the converged network adapter. So we can use those container network interfaces to plug into those automatically deployed networks. And then streamline operations. A new feature coming out with vSphere 7 is, if you've deployed NSX-T as of yet, you may have seen something called an NVDS. The NVDS concept will still be there in your edge nodes, but on the ESXi host level, if you're vSphere 7 and 3.0, instead of having to build another NVDS that may require additional PNICs, you can leverage the integrated VDS or the converged VDS. In other words, just a VDS with the NSX-T code kind of on top of it, if you will. So now we don't have to worry about either migrating adapters into the NVDS or having separate adapters just for the NVDS. We can just keep the VDS and we can basically slap the NSX-T code base right on top of that. So that's important. NSX-T policy integration with Terraform for automation, and Ansible if you like to automate and script, additional alarms and SNMP traps, and OpenStack Neutron integration, IPv6 support, VPN as a service, and policy plugin. All these features now in the latest release of NSX-T. But to wrap it up and keep it simple, just remember the core features are networking and security, just now extended for the modern application stack, and better operations as we go forward. That wraps up this presentation. Thank you very much for joining us, and we'll see you in the next video.